In this video, we're going to look at adding and subtracting rationals, which means adding and subtracting fractions. This is actually trickier than multiplying and dividing fractions or multiplying and dividing rationals. So it is very, very important that you recall some of those skills with the numbers that you did in elementary school. Let's start out with numbers. Let's say I had the fraction 1/2 plus 3/4. Well, in order to add or subtract fractions, you have to have a common denominator. That means the number in the bottom needs to be the same. In this case, they're not the same. I have 2 and 4. However, I can rewrite the first fraction as something over 4 by altering it just a little bit. I know that 2 times 2 is 4. So if I were to multiply the denominator by 2, I would have a denominator of 4. However, we can't change the value of the fraction, so I have to multiply by 2 over 2, which is essentially just multiplying it by 1. When we do this, we end up with the fraction 2 over 4 plus 3 over 4. So I'm taking 2/4 and I'm adding 3/4. So at the end of the day, I'm ending up with 5/4. 5/4 can't be simplified any further, so we're done. That is the addition of 1/2 and 3/4. So let's try another number problem so we can kind of get a feel for finding those common denominators. Let's say I had 10 over 9 and I wanted to subtract 5 over 24. This one's a little bit trickier because I can't just change one of the denominators to equal the other one. So here's where factoring is going to come into play. Let's factor those denominators for a second. 9 is 3 times 3. 24 is 3 times 8. So they both have the 3 in common. So really, we just need to alter the first one a little bit. We don't have to totally go with multiplying 1 by 9 and 9, multiplying 1 by 24 and 24. They already both have a 3. So the first one just needs an 8. That's all I need to add to that one. The second one needs another 3. So we can multiply this first fraction by 8 over 8, because that's what I need to have in my common denominator. And we can multiply the second fraction by 3 over 3. Now think about what I'm going to have in the denominators of both these fractions. I already had 3 and 3, and now I'm adding in an 8. For this one, I already had 3 and 8, and I'm adding in a 3. So if you look at these, we have common denominator of 3 times 3 times 8. That's all I was doing here. So now let's figure out what those things are going to look like. 8 times 10 is 80 over 8 times 9, which is 72. We're going to subtract 5 times 3, which is 15, over 24 times 3, which is 72. So we found our common denominator. Could you have used 9 and 24? Sure, but you would have had huge numbers. So it's really important that you paid attention to what we did down here to get that 72. We knew they both already had the 3, so we didn't need to add it. But this one was missing the 8, so we needed to add the 8. This one was missing 1 3, so we needed to add that too. Now let's go ahead and simplify our fraction. 80 minus 15 is 65 over 72. Now we can try to simplify that a little bit further if we wanted to. You can try to think of some of the factors of 65 and the factors of 72. But because we were careful and used the least common denominator, I'm writing it all out because it's super important. Since we found the least common denominator as opposed to just a common denominator, I know that my final fraction is in the most simplified form. That's what we're going to be looking for, the least common denominator. That means we're going to need to have the exact same factors in the bottom of each fraction. Maybe you're thinking, okay, why are you harping on this? I know how to add and subtract fractions. Well, you do with there's numbers. It gets stickier when I'm having to deal with factors like x plus 5 and x plus 7 and things like that. So it is very important that we consider this step. What did we do? We made sure that they had the same factors in both. So here's a fraction with those big nasty terms like I was talking about. And we're going to start out by doing the same step we started with in our multiplying and dividing. We're going to start out by factoring everything. So I have r plus 6 over 3 times r minus 2. I'm going to add that to r plus 1 over 3 times r minus 2. Now if we look at those two denominators, they're actually already common denominators. They both have a factor of 3, and they both have a factor of r minus 2. So the least common denominator between the two of them is 3 and r minus 2. I'm good to go. I can add these fractions together. Think about what we did when we added the number fractions. We just added the numerators and we kept the denominator the same. So I'm going to do r plus 6 plus r plus 1 over that least common denominator of 3 times r minus 2. So when we actually do this math, r and r makes 2r, 6 and 1 makes 7, over 3 times r minus 2. Now I know I can't factor the top any further, and the bottom is already factored, so I'm done. You might be tempted to want to distribute that 3, but you really don't need to. Again, factored form is really what we need in order to think about rationals, to graph rationals, and to determine information about what that expression tells us. So leave it in factored form. That's your best bet. Alright, so this one's a little bit trickier. I can already tell I don't have a common denominator. But let's still start out the same way. Let's factor first. So we're going to factor the first fraction, and we're going to factor the second fraction. First fraction actually doesn't factor at all. Second factor only factors a little bit. Alright, so let's evaluate our denominators. If I look at this denominator, I have a factor of x plus 3. If I look at the second denominator, I also have a factor of x plus 3. So I'm actually on my way to a pretty good least common denominator. The least common denominator needs to have the fraction x plus 3. Now, if I look at the second fraction, though, I also have a 2 in the denominator, which means that also needs to be represented in the least common denominator. That means that the LCD is 2 times x plus 3. This is kind of nice because the second fraction doesn't need to be changed at all. The first fraction does. It needs to have a 2 in the bottom. So if I'm going to get a 2 in the bottom, I'm going to need to multiply by 2 over 2 so that I don't change anything. So when we do that, we end up with the fraction 2 times 5x minus 1 over 2 times x plus 3 plus 3x over 2 times x plus 3. Do not be tempted to cancel those 2's out. They should both be there. We just purposefully put them both there. So let's go ahead and move to our adding. We have a common denominator, so we can go ahead and add the numerators, keeping the denominator the same. So I have 2 times 5x minus 1, and I'm going to add 3x to that. I'm going to actually write this out the long way. Some of you guys are going, oh, I know what to do from here, and you know what? Yes, there's a shorter way to do this. You could distribute, but I'm going to do each little step in between. So I see I just added the numerators. So what that gives me is 10x minus 2 plus 3x over 2 times x plus 3. Now it's just a matter of simplifying, adding the top, combine like terms. 10x plus 3x is 13x minus 2 over 2 times x plus 3. Can't simplify it any further because I can't factor, so I'm done. that's the addition of those two original fractions that we had with their least common denominator of 2 times x plus 3. So for this problem, if we want to subtract these two fractions, we need to find the least common denominator first. Well, the denominator of the first one is x plus 4. The denominator of the second one is x minus 4. So keep in mind that the least common denominator includes both denominators. In this case, I have to include both those factors in the least common denominator, which means the LCD is going to be x plus 4. That takes care of the first one. And it also has to have the factors of the second one, which is x minus 4. So I'm going to have to do a lot of work for this one. I'm going to have to change the denominator of both fractions completely. So to get the least common denominator in the first fraction, I'm going to need to multiply by x minus 4 in the denominator, which means I need to multiply by x minus 4 in the numerator. Ditto for the second one, except this time we're multiplying by x plus 4 to get the LCD, which means we need to multiply the top by x plus 4. So when I actually carry out this multiplication, I know that my denominator is going to be x minus 4 and x plus 4 in both fractions. Leaving it in factored form because, again, this is how we're going to want to leave our answer. In the numerators, though, since we will combine them, I'm going to distribute. If it's okay with you guys, I'm just going to distribute right away. So I have x minus 4 times x minus 3 to become the numerator of the first fraction, which means I'm going to have x squared minus 7x plus 12. I'm going to do a similar thing for my second fraction. I'm going to do x plus 2 times x plus 4, which means I'm going to have x squared plus 6x plus 8. So now I can go ahead and subtract my fractions. Since I know they're going to have that denominator, when you add and subtract fractions with a common denominator, the denominator stays the same. I'm going to go ahead and write that down for now. Then when I subtract my numerators, I'm going to have the first numerator minus the second numerator. The trick with this is you have to subtract the whole numerator. My fraction bar isn't big enough. So that's why I put it in parentheses. Help me remember to distribute that negative. This step that I just wrote down is one that a lot of you guys will start skipping very quickly, and you'll go straight to the next fraction I'm going to write, which is the simplified fraction. So I know my simplified fraction has x minus 4 and x plus 4 in the denominator. Now, I have x squared, and I'm going to subtract x squared, so I have no x squareds left. I have negative 7x and minus 6x, so that gives me negative 13x. I'm going to have 12 minus 8, and that leaves me with 4. So negative 13 plus 4 is my numerator. Sometimes you can factor the numerator a little bit further and maybe even cancel some stuff out. In this case, I know that there's no GCF between negative 13x and 4, so I'm done. I can say that my answer to this subtraction problem is that final fraction right there. Alright, this is a good one. If we look at this subtraction problem, I have some pretty complex denominators. I'm going to want to factor them first. So when we end up doing that, we'll be able to see what we need to create our least common denominator. When I factor the first denominator, I have x minus 3, and I have x plus 2. 3x can't factor any further, so I'm going to leave it 3x. In the second fraction, again, I can leave the numerator in this case. Then I'm going to factor the denominator. So I'm going to have x minus 3 times x minus 5. So we need our least common denominator. The least common denominator, remember, needs to include all the denominators. If I look at the first one, I know I need x minus 3. And I'm going to need x plus 2. And if I look at the second denominator, I need x minus 3, which is already included. I already have that. So I also need x minus 5, though. So I'm going to add that to my least common denominator. So I ran out of space. I'm going to rewrite it. X minus 3 needs to be included. X plus 2 needs to be included. And I'm going to need x minus 5. So now let's create that least common denominator in both fractions. If I look at the first fraction, see that I'm missing an x minus 5. So I need to multiply the first fraction by x minus 5 over x minus 5. If I look at the second denominator, I'm going to need to multiply that denominator by x plus 2. So I'm going to need to multiply the fraction by x plus 2 over x plus 2. Now, in the last example, I talked about skipping a step. I'm going to kind of do that here. My simplified fraction, I know, is going to have a denominator of x minus 5 times x minus 3 times x plus 2, because that's the least common denominator. If I look at the numerator, what I'm going to do is x minus 5 times 3x. So when I'm going to write that as 3x times x minus 5. Then I'm going to subtract what I get for the second numerator, which is 5, times x minus 2. So I'm going to say minus 5 times x plus 2. I said minus earlier, I meant plus. Alright, so now we can simplify a little bit. Again, that least common denominator is going to be x minus 5 times x minus 3 times x plus 2. These problems get pretty long. I hope I have enough space. To find my numerator, I'm going to need to distribute a little bit. I'm going to have 3x squared minus 15x minus 5x minus 10. Alright, I'm running out of space. Let's see. I'm going to come over here. Simplifying the new numerator, I get 3x squared minus 20x minus 10 over that big giant least common denominator. Now, sometimes our numerator actually factors a little bit further, so you would want to think about factoring the numerator. See if you can think of anything that would simplify it. In this case, though, there isn't a way to factor the top. The top does not factor. So we can definitively say that our final answer is just 3x squared minus 20x minus 10 over x minus 5 times x minus 3 times x plus 2. Again, I'm going to leave my answer in factored form because later on we will want factored form to tell us some things about this particular rational. From here on out, I'm mostly just going to be doing lots of examples, so if you think you have this down, you might want to pause the video, try this example, and then wait to see, go back and see what I did, see if you got it right. As with any of these problems, we want to factor it first to figure out what our LCD is, what our least common denominator is. So I'm going to factor as much as possible with these two fractions. For the first one, I can factor the denominator. I can pull out the 2. So that leaves me with 2x minus 1. X doesn't factor, it stays x. The other fraction, I actually can factor both the numerator and the denominator. When I factor the numerator, I get 3x plus 3 times x plus 1 over 2 times 2x minus 1. Sometimes this is really nice and you can cancel something out. Unfortunately, we can't cancel anything out. That's the whole point of factoring first, though, is to see if there's a way to make your problem simpler. When I'm looking at these two denominators, they're actually already the same. The least common denominator, remember, contains the factors of all the denominators. So one factor is 2, and one factor is 2x minus 1. If I look at the second fraction, it already contains the 2, and it already contains the 2x minus 1, and I don't need to add anything else. So I'm ready to go. I know that when I simplify this, my simplified fraction is going to have the denominator 2 times 2x minus 1. In my numerator, I can go ahead and add those. I'm going to have x plus 3 times x plus 1. Now we can simplify a little bit by distributing. We know we're still going to have 2 times 2x minus 1. And in the numerator, I can distribute the 3. So I'm going to end up with x plus 3x plus 3. So that factor I did earlier was actually kind of unnecessary. Now let's simplify this a little bit further. I end up with 4x plus 3 in the numerator and 2 times 2x minus 1. This new numerator does not factor any further, so I am done. That would be my simplified fraction representing the sum of the two original fractions. Score. This one has 3 fractions. Awesome. We can still do it though, because remember, whether I'm adding 2 fractions or whether I'm adding a million fractions, as long as they have a common denominator, I can just add the numerators and keep that common denominator the same. So let's factor this thing a little bit so we can see if we have or what we need in order to find the least common denominator. In this case, I know for sure that they already aren't the same. So the first fraction actually doesn't factor any further, and I'm done. It's 2 over x plus 1. The second fraction does factor a little bit. I can factor out the 3, so I get x plus 1 times that 3. And in the next one, I can factor out the 2 in the denominator, and I get x plus 1. Now what I would do next, before I would try to find the least common denominator, was I would simplify as much as possible. I can actually simplify the middle fraction a little bit. I can cancel out the 3's. So the problem I'm really going to be concerned about is 2 over x plus 1 plus 1 over x plus 1 plus 1 over 2 times x plus 1. Now let's find that least common denominator. According to the first fraction, I need to have an x plus 1. According to the second fraction, I need an x plus 1. Score, I already got it. According to the third fraction, I need an x plus 1. Again, yay, I already got it. But I also need a 2. So the least common denominator is going to be 2 times x plus 1. Which means I only need to change 2 of my fractions. I'm going to need to multiply the first fraction by 2 over 2 and the second fraction by 2 over 2 so that they contain that least common denominator. So I'm going to end up with 2 times x plus 1 as my least common denominator. The numerator of the first fraction will be 4 plus the numerator of the second fraction, which is 2, plus the numerator of the last fraction, which was 1. Now, if we simplify this a little bit, we're going to end up with 4 plus 2 plus 1, which is 7, over 2 times x plus 1. So, look to see if you can simplify it any further. Unfortunately, 7 and 2 don't have any common factors, so we're actually all finished. Again, I'm leaving my answer in factored form. Mixing things up a little bit here. I'm using a's and b's instead of x's. We're still going to do this the exact same way, though. We're going to start out by factoring whatever we can factor. The first fraction does factor. AB stays AB, but a squared minus b squared is a difference of squares, which means it factors out to be a minus b times a plus b. The second fraction doesn't factor at all, so I just have b over a plus b. Now let's figure out what our least common denominator is. According to the first fraction, it needs to include a minus b and a plus b. According to the second fraction, it needs to at least have a plus b. Done. So I don't need to change 2 too much. I just need to change the second fraction so that the denominator also includes the a minus b, which means I need to multiply it by a minus b over a minus b. So let's go ahead and let's do that. I know I need my least common denominator of a minus b times a plus b. The first numerator is ab. I'm going to add the second numerator, which is b times a minus b. Alright, well this simplifies a little bit. I'm going to end up with ab plus ab minus b squared over a minus b times a plus b. Okay, let's simplify a little bit further. I'm running out of room. I'm coming over here. So I have 2ab minus b squared over a minus b times a plus b. Now, we can actually factor a little bit on the top. To redo the top, though, I'm going to rewrite it in standard form, b squared, negative b squared, plus 2ab. Again, that denominator. So it looks like I can factor out a common factor in the numerator. They both contain a b, so I can factor out a b. And because it starts with a negative, I'm going to factor out a negative b. When we factor out negative b, we're left with b minus 2a. If life were wonderful, we would actually be able to cancel some stuff out. Unfortunately, there are no common factors on the top or the bottom, so I am done. Put a box around it. Factored and added. This is the last example I'm going to do in the video. There's lots of places for you to find other examples of these types of problems, and I highly suggest you search them out because they do get very, very tricky. At first glance, these denominators look sort of similar, but they're not exactly the same. So to figure out what my least common denominator is, I'm going to factor these. What I am going to do for the first fraction, though, I'm going to rewrite it with x in front. I like to have my factors starting with x. It makes it a little bit easier to see what's going on. So let's go ahead and factor. The first fraction doesn't factor any further, so I can leave it as is. The second fraction actually can factor a little bit. Let's factor the negative 1 out of the bottom, and we end up with negative 1 times x minus 5. So the least common denominator needs to include a negative 1 and an x minus 5. So I'm not too far off from my least common denominator. Another thing you can do, though, is remember that this negative 1 can apply to either the top or the bottom. The negative sign can go with either one. So I'm really just going to change this into a minus problem and ignore that negative 1 down there. I'm including the negative 1 already, but by changing it to a subtraction problem, my least common denominator becomes simply x minus 5. Since both of those fractions already have x minus 5, to me it's simpler to keep it as a subtraction problem rather than multiplying the first one by negative 1 and then adding the two together. So now that we have it set up and ready to go with the least common denominator of x minus 5, I can carry out my subtraction problem. In the numerator, I am going to have x plus 2 minus 3 because I changed it to a subtraction problem. Now we can simplify this a little bit. We're going to end up with x minus 1 in the numerator and x minus 5 in the denominator. Nothing factors any further. Remember, you can only cancel out common factors, not common terms. So I'm done. The addition problem simplifies to be x minus 1 over x minus 5. Adding and subtracting is one of the hardest things that we have to do with our rational functions. So like I said, it's important for you to practice this. Go seek out some extra resources. Do some problems that you can check yourself on. Like I said, you'll find those on the resource pages. Now let's do a recap. So, just like all the rest of the rational stuff we've done, the very first step that you need to think about is factoring. You want to factor everything first. You saw in some of those examples that by factoring everything first, our least common denominator was way easier to see, and sometimes we actually didn't have to do very much at all. Once you factor everything, you need to find the common factors in each fraction to simplify, like we did on the problem with 3 fractions. This doesn't happen very often, but when it does, it's usually to your benefit to get rid of them. Your least common denominator is more simple. Then you need to find the LCD, the least common denominator. Usually that involves adding, or usually it contains the denominators from all the different fractions that you're adding or subtracting. Once you have your least common denominator, you're going to multiply each fraction so that it has that least common denominator. Then, just like any other fraction problem, you add or subtract the numerators as you normally would, and the denominators remain the same. Once you finally do that, you can simplify your final fraction if possible. Sometimes this wasn't possible, sometimes it is possible. So those are the steps to adding and subtracting rational expressions.